Hello, this is John from caveofprogramming.com. In this tutorial, we're going to look at returning objects from methods in C++, and we're going to get a bit more sort of practice with the new operator. So in a previous tutorial, I showed you this class animal, which very simply has a constructor, copy constructor, destructor, set name method, has a name instance variable, and a speak method that outputs name. And the constructors and destructors all output some text so we can see what's going on there. And we've seen this little program before. Let's get rid of this, which just uses the new operator to allocate memory for an animal object, and it calls set name speak, and then it deletes the we call delete on the pointer to deallocate the memory associated with this object, which means the destructor is called. So supposing you want to return an object from a method, and this is a common thing to do in C++, well, let's say from a function. Of course, a method is just a function, it's part of a class, but let's create a freestanding function here. I'm going to say animal, let's call it create animal, and put the curly brackets in there if I can remember where they are on this keyboard. And in there we could instantiate a animal object like this. Let's call it A, and a.setName Bertie, and return A. Now in our main program here, let's say animal frog equals create animal, and of course we can call frog.speak. Now this does work. So if I run this, it says animal created when we do that. It says my name is Bertie when we do this, and then destructor called when this variable goes out of scope. Now the funny thing is, if you understand a bit about how this works, we would expect this to be quite inefficient, although it seems that on this system with this compiler it actually isn't. So what we'd expect to happen is, here we're creating an animal, it's a local variable, calling set name. When we return an object from a function, we actually have to normally C++ will create a temporary object just to return that this object. So it would actually copy this, you'd expect, to a temporary object just to have the return value in there. And then when we do this, when we assign this new object here to our temporary return value object here, we'd expect that another copy would occur. So what we'd expect would be the constructor would be called. When we do return, we create a temporary return object to return into this variable here, in effect. So we'd expect the copy constructor to be called there, and we'd expect the copy constructor to be called here when we do this as well. In fact, we're not seeing the copy constructors here, and that's because this particular compiler is optimizing out the two copies there. So it realizes that we don't want them, we just basically want to have one animal here, and it's optimizing away the extra copies. Nevertheless, in theory, this could be potentially inefficient if that optimization with some compiler or other didn't actually happen. Now, we could think about how to make this more efficient, and a kind of naive way of doing that would be to return a reference. So we could change that to a reference, and then we could think, okay, when we return it, what will happen is that we'll just return a reference to this animal, in other words, just an alias to this variable, and then maybe we can make this a reference as well, like that. Then we can say, okay, this is just going to be an alias to this. Now this works as you'd expect with regard to references, but the problem is that, well, let's just build it. We get a load of warnings. So I don't think we've got any errors in here. It has actually built a program, but the program is probably going to crash. I'm not going to try running it, but it's not a good program. The reason for that is this variable here is scoped to these curly brackets. So when we hit this curly bracket, the destructor is going to be called on this, we'd expect. And therefore we end up with a reference to an object that no longer exists. So that if the kind of sort of instance variables of that object are still present in memory, it's purely by chance. I imagine they won't be. I'm really not sure what would happen if we run this. Well, let's just try it, what the hell. So it seems to have worked. It just say Bertie, but that's really worked by chance more than anything else, just because I suppose, although this ends up referring to invalid memory, that memory just happens to have the right stuff hanging around with it. But anyway, regardless of whether this works or not, this is a very, very bad thing to do. Returning a reference to a local variable which will go out of scope is not a good idea. Your program will randomly crash. So a common way to get around that is to use a pointer. We could say here animal, let's say p animal equals new animal, like that. We need to put the star in there as well, and then we can return a pointer here to this animal. We can do p animal arrow set name using the arrow syntax now because it's a pointer, and then we can return p animal. Here in our main program we can say, let's say p pointer p frog equals the return value of create animal, and then we can say p frog arrow speak, like that. But the thing that we mustn't forget to do is, because this function did a new here, we must do a delete to deallocate the memory associated with this frog. So we need to say delete p frog, like that. So even though the new happened in a whole other method to this one, sorry, a whole other function I should say, we still need to do the delete because we do have a new, and we've got to deallocate the memory that we allocated with new, otherwise we'll have a memory leak. Let's save that and run it and check that it works. So now we've got my name is Bertie destructor called, we've got a constructor being called and a destructor, and there are no copy constructors because there's no copy happening of the animal. Even without compiler optimization there wouldn't be a copy here. We're creating, when we return the pointer, we're creating a copy of the pointer, but that's just copying like an 8-byte memory address. And similarly here, when we get that temporary return value into pfrog, at least this is my understanding of how it works, we're just copying 8 bytes. Did I say bits? We're copying 8 bytes into this pointer variable here. So even if this animal is huge and occupies, you know, like, I don't know, megabytes, then we're not creating copies of those megabytes, even if the compiler doesn't optimize to get rid of the copies. We're still not doing it because all we're doing is passing around a pointer. This is a much more efficient way of doing this. We're returning an object from a function than if we tried to do it without pointers. And it also avoids the problem that we saw with references, because if we didn't have a new here, then we'd end up with that animal being destroyed at this point, and we could end up returning a reference to an animal that doesn't exist anymore or may not exist. But with a pointer, that memory will not be deallocated until we do delete on it. So this, with new, you have to do delete to explicitly deallocate that memory, and the memory will hang around associated with this, the object that this pointer points to, until we call delete. So that's why this is safe to do. It just has the downside that you don't see a new here in this function, but there is a new there, and you must do delete. So this is not the nicest thing to do, but you see this a lot in actual production C++ code, because sometimes you just need to do this sort of thing. So to practice this, just create your own function that returns a pointer to an object, and then use the object somehow and delete the memory associated with it. And once you've done that, that'll help to make it stick in your memory. There's one little thing that I should mention here, which maybe we'll go over in a later tutorial because it is important. But there are two basic areas of memory in a C++ program, or at least classically this is how we think of it. And as far as I know, it's basically true. And that is, we have the stack and the heap. And the stack is an area of memory. You can think of it like a stack of plates where you can put plates on the top and then take plates off the top, except that what we're putting on the stack is memory associated with local variables. Like the pointer itself is a local variable in this case. And also we put the addresses of functions to be called onto the stack so that we know how to call those functions in what order. So local variables and function calls end up adding memory to the stack, and the stack is a small area of memory. If you called a function from within itself over and over again, so that it ended up calling itself, you know, millions of times, you can end up with a stack overflow by exceeding the amount of memory that you've got on the stack. But there's also an area of memory called the heap, and this is basically all the memory available to your computer. And when you do new, you're actually allocating memory on the heap. So let's say you had an array with millions of entries in it. You don't want to declare that as a local variable because it could overflow the stack. You would want to use new to allocate memory on the heap, which is much bigger for that array. And we're going to be looking at that in a future tutorial. So I'll leave it there for now. Just try creating your own function, if you like, that returns a pointer to an object it creates with new. And don't forget to delete. It's very, very important. It's worth putting in your constructors and destructors and put some text in them so you can verify that they are actually called. So until next time, happy coding.